Welcome back to Practical PyTorch. Last time you built the loss, the one number that says how wrong your model is. In this video you'll take the step that makes it smaller. That's the optimizer. You'll meet SGD and Atom and the one dial that decides whether training works, the learning rate. The gradient points the steepest way uphill. Step the other way and the loss goes down. But the gradient does not tell you how big a step to take. That choice belongs to the optimizer, how far to move the weights each step. Get the size right and the model learns. Get it wrong and training fails with the very same code and the very same data. This video has 4 parts. First, one optimizer step. W becomes W minus the learning rate times the gradient. Second, the learning rate itself, the number that sets how far each step goes. Third, what happens when the step is wrong, too small or too big. And fourth, momentum and atom, the safe default you'll reach for most. Let's start with a single step. One step of training nudges the weight a little way downhill. We start with a weight W, set to 1.0, and we ask it to track gradients. The loss is the same bowl from the last video. Backward fills in the slope at this W. Then we read the slope and take the step by hand, W minus 0.3 times the slope. The slope is minus 7.2, and the learning rate is 0.3. So W moves from 1.0 to 3.16. That's the whole rule. W becomes W minus the learning rate times the gradient. This same update has a name, stochastic gradient descent. In PyTorch, it's torch.op.SGD. You still call backward to fill in the gradient. And opt.step takes the step, W minus the learning rate times the gradient. That lands W at 3.16. Opt.step is exactly the line you wrote by hand. Nothing new happens. You hand SGD the tensors to update in the learning rate. It applies the rule to every one of them. Before each step, opt.0grad clears the old gradient. Then backward computes this step's gradient. Then opt.step takes the step. Say the order out loud. Clear, compute, step. Skip 0 grad and each backward adds to the old gradient instead of replacing it. The step sizes grow wrong and training drifts. Now the dial that runs the whole thing. The learning rate decides how far each step goes. With a good learning rate, 0.3, the loop steps the dot down the bowl. It starts where the last video left it, high on the left arm. Step 0, W is 1.0 and the loss is 14.4. The loop prints one line per step, and opt.step moves the dot down. Here's where we started. Now left behind is a hollow marker. The first step takes a big stride toward the middle, because the slope was steep. Step 1, W jumps to 3.16, the same number we computed by hand, and the loss drops from 14.4 to 3.047. A second hollow marker shows the last spot. The slope is gentler now, so this step is smaller. Step 2, W is 4.154 and the loss is down to 0.645. The learning rate never changed. Near the minimum, the slope shrinks, so the step shrinks too. The rule breaks itself. Another marker joins the trail. One more step, and the dot is nearly at the lowest point. Step 3, W is 4.611 and the loss is 0.136. That's a small fraction of where it began. One more step lands it. The 4 hollow markers trace the whole path down. After 4 steps, the dot rests right near the bottom. Step 4, W is 4.821 and the loss is 0.029. Look how far the loss fell, from 14.4 to 3.047 to 0.645, then to 0.136 and down to 0.029. That's training working. A good learning rate walks straight to the bottom. The learning rate is that one dial. A small one takes tiny steps, a large one takes big steps. 0.3 walk the dot down in 4 steps. The next 2 slides change only that number and training breaks both ways. That worked because the learning rate was right. Now let's break it twice. Once with a step that's too small and once with a step that's too big. Set the learning rate far too low, and every step is a crawl. The markers barely leave the start. After several steps, the dot is still high on the arm, nowhere near the bottom. Nothing is wrong with the code. The learning rate is just too cautious. It would take hundreds of steps to reach the minimum, training that never seems to finish. Now the opposite mistake. We set the learning rate to 3.0, 10 times the rate that worked. Same loop, same data, same start, only the learning rate changed. Watch what one step does with a stride that large. One step leaps clear over the minimum. It lands on the far side, higher up than it started. Step 1. W shot from 1.0 all the way to 22.6, and the loss went up from 14.4 to merely 279. A loss that rises after a step is the warning sign. The step is too big. The next step is off the chart. A red arrow flies off the corner. Watch the loss climb. 279, then 5,000, then 100,000. By step 4, it's over 2 million. Same code, same data, same start. Only the learning rate went from 0.3 to 3.0. A learning rate picked by feel is how training quietly blows up. So the learning rate has to be just right. 2 tools make that much easier: momentum and atom. Plain SGD can crawl through flat stretches. Momentum fixes that. Here we add one argument, momentum of 0.9. Momentum adds a fraction of the last step to this one. Steady downhill motion builds up speed and small wobbles cancel out. Picture a ball rolling downhill, keeping some speed from the moment before. 0.9 is the usual value. Atom goes further. It adapts the step for each weight, so a good learning rate is easier to find. A common starting point is 0.001. Atom adapts each weight step from its own recent gradients, which makes it forgiving about the learning rate. When you're not sure, reach for Atom with a learning rate of 0.001. Let's bring it together. For plain SGD, one step is W minus the learning rate times the gradient, and opt.step does exactly that. Momentum and atom build on the same idea. The learning rate sets how far each step goes. Too small and it crawls, too big and it diverges. Same code, opposite outcome. Atom with a learning rate of 0.001 is the safe default, and always clear the gradients with 0 grad. Quick check before we go. W is 1.0, the gradient is plus 2.0, and the learning rate is 0.1. What is W after one SGD step? Pause the video and predict. Here's the answer. W is 0.8. 1.0 minus 0.1 times 2.0 is 0.8. The gradient is positive, so the step moves W down, the way that lowers the loss. That's the sign trap. A positive gradient steps the weight down, not up. You now have the step. You can move the weights the right amount down the curve toward the minimum. The optimizer takes one step. The training loop takes thousands. Zero the grad's forward loss backward step over batch after batch. The next video puts the whole loop together, the loop you've now seen every piece of. See you there.